I'm going to talk about deriving equations. Deriving equations is something you're going to do once again in every unit of physics. That's why I'm calling this unit 0. It's just something you got to know how to do. And the best way I can explain it is with like solving without numbers. And I'm gonna explain it. First, let me get a problem up here. Okay, so this is just like a kinematics like problem I came up with on the spot. Don't flood it if you don't know how to do it yet. All right, this is just unit 0. I'm not gonna have a kinematics lesson here. I would wait until, if you don't know how to do this, wait until the part in your physics class where you learn how to do this. You can come back and this will probably make some more sense. But I'm just gonna show you how you would solve it regularly and how that kind of applies to deriving equations. If I just want to solve this regularly, I just got to think of a physics equation I'm going to use. So it's looking for time, so I'm gonna think, okay, well, so I might use like the change in x, or I guess change in y equals 1/2 a t squared plus v naught y times time. And I'm like, okay, I'm solving for time, so this is gonna equal 0. So like one strategy I'm doing to solve this equation is that it's gonna kind of stop, or sorry, by the time it's back down to the ground, it will have displaced 0, right? It just starts and ends at the same spot. So 0 meters is gonna equal, and then I'm gonna think, okay, 1/2. What is my acceleration? I'm just gonna say -10. It's really 9.8, but I'm just gonna say -10 to kind of make this easy on myself. Meters per second squared. I'm solving for t, and I'm gonna have plus v naught y is 30 meters per second times time. All right, and then algebraically, I'm gonna say, okay, 0 is gonna equal 1/2, so -5 meters per second squared, t squared, plus 30 meters per second times time. And now, what I'm gonna do is I'm gonna, okay, well, I wanna solve for t. Let me get them both on both same side, so 5 meters per second squared, right? Adding t squared is gonna equal 30 meters per second times time. And then I'm gonna think, okay, awesome. So now I can get rid of one of these t's, and then I can get that, so if I divide everything by 5, I get t is gonna equal 6 seconds, right? That's how long it's gonna be in the air for. So that's how you can solve it with numbers. Now, how do you, let's say we switch up this question a little bit. A ball is launched v naught up into the air. How long is it in the air for? So a ball is launched v naught. We don't know its upward speed. So you can imagine it's kind of impossible to get a number for, right? Like, I don't know how fast it's moving up, and maybe I don't like if it's gonna be 1,000,000 meters per second up into the air. That's different than if it were just 10 meters per second. You're not gonna get a number. So what this is implying, usually when they just give you variables and no numbers, that's usually suggesting deriving an equation. So deriving an equation is just solving without numbers. I'm going to do the same steps I did here. I'm going to be like, okay, what's a physics equation I can use? Maybe I can use my kinematics, change in y equals, I'll do it over here, equals 1/2 a t squared plus v naught times time. Okay, well, what if I change in y? I can use the same strategy I did here. I can switch it up if I want to as well, but I'm just gonna use the same strategy. There's a few different ways you can solve this, but I'm gonna be like, okay, change in y is 0 meters per second, or sorry, it's 0 meters, right? I haven't displaced anything. Now, 1/2, for deriving, you usually want things in terms of variables. I'm just gonna put in -g. Instead of having an actual number, I'm going to put in -g. And the reason for this is because, well, you could probably put 9.8 if you want, but when we put g, that's just the variable form of the gravitational acceleration, or acceleration due to gravity, 9.8 meters per second, or whatever, plus, and now v naught times time. I don't know what v naught is, but I'm just going to leave it there. So now I'm just solving for v naught, or t, sorry, I'm solving for t. So I'm going to get, okay, I'm going to get 1/2 gt squared is going to equal v naught over time. I can cancel out one of those t's, and now I'm going to get t is equal to 2. So I'm solving for t, right? So I'm going to multiply both sides by 2 and divide by g. I get t is equal to 2 v naught over g. This is pretty cool, actually, because now what you can do is, let's say you do know that this, let's say in the next part of the problem it says, yeah, the speed is 30 meters per second. Instead of just going through this whole step again, I just did the same thing without numbers. Now I can plug in 30 as v naught and then negative 10, or sorry, yeah, 10, wait, I messed up somewhere. Oh yeah, I could just plug in 10 where like, it's like the, you know, the size or whatever. 2 v naught over g, 2 times 30 over 5, well, 30 over 5 is, wait, did I mess up here? Sorry, it should be 10. 30 over 10 is 3 times 2 equals 6. I just get 6 seconds just from this simple equation. So that's really what deriving equation is. I just did the same thing, but I just solved without any numbers. I'm still solving for t, I just don't know any numbers. So I'm not gonna like divide by 5, I'm gonna divide by g. I'm gonna multiply both sides by 2. So it's just solving for without numbers. Hopefully that makes sense. This is a skill that you could practice. I think explaining it is kind of helpful, but just get some practice, and I think you'll be in good shape.